Okay.
broadcast. Um, well, that's nice of you guys. That's really good.
Yeah, we'll see how it works out. I think a couple of his brothers have tried, and it's kind of hard.
Yeah, it
Yep.
is stressful, especially Alzheimer's. That's so hard to deal with because, they forget, like my grandma's coming down with all like the first beginning stages of Alzheimer's, and like my uncle and aunt take care of her, and it was hard for a while. I had to fly down one weekend because they always take care of her. It's her son, and she was like, "They're stealing all my money, Kim. Like, you need to come down here. I don't want to talk to anybody but you. I'm telling them to leave me alone. I'm never opening." And she can't take care of herself, but she just got super paranoid, and you know,
Mhm.
I had to prove to her, like, okay, they're not stealing your money. You know,
That's how my grandma was. They get kind of paranoid.
yeah. So I mean, don't. Obviously it's not them. They're not in their right
Yeah.
mind. So,
Yeah. And that's the hard thing too. I mean, I don't know.
yeah, because I mean, they seem like one day they seem with it, and the next day it's like they're crazy. Or
Yeah. Yeah.
not
And
the,
it,
the thing.
yeah, it's so frustrating, but they can't help it. They don't mean it.
Right. It's just, I think it'll be good to have you and your husband there because, like, you can mentally help each other. You know what I mean?
Yeah. She's really not that bad yet. She's still kind of early stages, but she just needs help remembering to take her medicine and remembering to eat. So, anyway,
Um,
we can do that.
yeah, that'll be good. Well,
Yeah.
good. Okay. Well, shall we start?
Yeah, let's get started.
Okay. So, it seems like we both kind of understood. I felt okay in going through it. I mean, I didn't have any major questions that make sense.
Uh-huh.
Just I understand the quiz when we open it. You know what I mean? I just didn't have a lot of time to study as much as I want to do. So we'll open group 10. Does that sound good? The
Yep.
test?
Mhm.
No, fine.
Okay. Trying to figure out how I did this last time. Like getting everything up.
Yeah.
Oh, okay, hold on. Oh, hmm.
Okay, just let it open.
Do you have yours open?
Yeah. I'm going
Okay,
to
so
start off the first one. Sorry, go ahead.
how do you get it where you can see both at the same time?
I don't. I see just my screen.
Okay.
And
Okay,
then
don't worry about it then. Let's see.
I see you guys, then I look at you. But normally I don't.
Okay. Let me just pull it up real quick then. So, L10 group meeting.
Okay, so I'm doing number 3 in my calculator right now.
Okay.
Just when you get there.
Yeah, I'll catch up here in a sec.
No, you're fine.
You know what? I think I'll just do it like this. Okay. Sorry it's taking me so long.
No, you're fine.
It does not want to open for me, so I'll try this again.
Your quiz won't open?
Yeah, to start the quiz.
Oh.
Okay. Maybe it'll do it this time. Oh, there it is.
Oh, Mom,
Yes.
I don't have any homework, and I did my piano in the morning, and I did a truck. Can I go play at James' house?
Yeah. Okay. Okay, see ya. Okay. So,
So
okay.
tell me, calculate out 3 and tell me what you get.
Okay. 90 times 50 over 5. Cool. Okay, did you get 16.45?
Yeah, that's what I got.
Okay.
Okay, so which of the following statements is true? I was trying to look this one up because I don't remember off the top of my head. Do you by chance know?
What is that? The little, do you see the second one? The second choice, how it's like a piece of paper, a dog-eared piece of paper. Do you see that?
Oh no, mine comes up. So I have sigma is an interval estimator of sigma.
Sigma squared.
Yeah, yes, sigma squared. So I have,
Okay.
it's a point estimator of x bar. Sigma is an interval estimator of sigma squared. X bar is a point estimator of u. Sigma u or squared is an interval of estimator of x bar.
Okay, I'm going to say the third one. X bar is a point estimator of mu. Because it's your, X bar is your sample
Okay.
mean, and mu is your population mean. So that's me. Guess there.
Why wouldn't u is a point estimator of x bar work?
Because when you do your calculations, you're doing your calculations with your sample.
Oh, right.
And then you use that to infer to the population.
Right. Okay, that makes sense to me. Okay. Okay, Gina wants to construct a 95% confidence interval for the GMAT score. She knows the standard deviation in 113. She selects a simple random sample of N64 and computes 526 using information question 58. What is the lower limit of the confidence interval? Okay, so.
Okay, so I'm not getting some of these things come up for me. Let's see, open
Like
image.
the numbers aren't coming up?
Okay, where it says she collects a simple random sample of size n equals 64 and computes, I just have like a blank there.
Oh.
What does she compute? And
Of x bar 526.
X bar equals 526.
Yeah.
Okay. I don't know why it's not showing that. That's weird.
That is weird. That's annoying.
Yeah, well, I think I pulled it up on the remote computer. You know, the thing, same thing you use for SPSS.
Oh.
They don't accept cookies or something like that. I don't know.
That's probably why.
Okay.
1.96. Wonder if Anthony forgot about this.
Maybe.
No. 64. Okay, I'm calculating it out right now, so
Okay.
I get.
Let's see.
Wait, okay, what did you get for this?
Okay, I'm still working on it.
Can you get a negative?
No.
Well, yeah.
Um, okay, so the lower limit I got 498.315. Because you said X.
Yeah, you're right. Sorry, that's what I got too. I just accidentally minus the 526 instead of minusing the 27.68 from it. That's why. That's what I did wrong.
Okay, so let me put that.
But I got 498.315.
Okay. Yep.
And we round to the third decimal place, so we're fine.
Yep.
So, okay. So the upper limit then is 526 plus 27.685. I got 553.685.
That's what I got. Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
It would increase, right?
It
I
would.
thought that's one of the things it talked about.
So the easy way to do this is you look at the formula and see if the two things you're comparing, are they on opposite ends, like one in the numerator and one in the denominator? If they are, when one increases, the other will decrease because they have an inverse relationship. If they're on the same, like they're both in the numerator, then if one increases, the other will increase. Because they're direct.
Size, the confidence interval, if Gina increased the sample size. So
the confidence interval has to do with the margin of error. So that's in the numerator. And the sample size is n, it's in the denominator. So whatever one does, the other one's going to do the opposite.
So the numerator's going to decrease.
Yes, because the denominator.
I talked about how it increases in the lesson.
Okay, hold on. What's the confidence interval? No, because as your sample size gets bigger, your confidence would. Like you wouldn't have to have as big of a confidence interval. You'd be more confident. Does that make sense?
Yeah, so it would get smaller. So it decreases.
I'm pretty sure. I'll submit mine first if you want. But I'm pretty sure, yeah.
Okay. What would happen to the width of the confidence interval if Gina changed it to 99% confidence interval?
Okay, so it would increase because your z-score
would increase. Wait, hold on. Okay, yeah, it would increase. Okay. Let's see. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of light bulbs. They know their standard deviation is is 400 hours. They want a 95% confidence interval with a margin error of 50 hours. What sample size do they need? Round up to the nearest one. Well, this is
I do. Mm-hmm.
Why do you not see your phone? Oh.
okay. Tell me what you got.
Okay, so I got 246.
Wait, so tell me how you got that, because that's not what I got.
Okay, so I have the formula as being n equals, in parentheses, z star times sigma divided by m, and you square the whole thing. Is that the right one?
Yeah, that's what I...
Okay, so, and then 95%, so that's 1.96 times 400. Let me just make sure I did it right. Stop. I'm in a meeting. And
and then you divide by 50, right?
and then I got 15.68, and I square that.
Oh, okay, okay. Let me see where you got it. Okay,
So then I got 245.8, and they want you to round up to the nearest whole number.
right. So what, yeah, I did, okay, that's right.
Okay. Okay, so the mean salary of actuary, what's an actuary, do you know?
No, I have no
Okay.
idea.
So the mean salary of actuaries is mu equals 100,000, and the standard deviation is 36,730. You're now interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance alpha equals 0.05. And your null hypothesis is mu equals 100,000, and your alternative is mu not equal to 100,000. So you collect a simple random sample of n equals 36 women's salaries and find that x bar equals 111,000. Use this information for questions 10 through 12. What is the lower limit of this 95% confidence interval? Round to the nearest whole number.
Okay.
Okay, did you get the margin of error yet?
Hold on, I almost have it.
Okay.
Okay, yeah. What was your margin of error?
I got 11,998.466.
That's what I got. Okay, and then so minus 11,000 minus our answer. So what did you get? 99001.53.
Yeah, I got 0.54, but it doesn't matter. They want us to round to the nearest whole number, so it'll be 99,002, right?
Yes, correct.
Okay.
Okay, so then what is the upper limit?
You don't need to put the dollar sign, do you?
I don't think so. I don't think we did it last time, did we?
I don't think so either. I think you just put numbers in there. Do you put commas?
I wouldn't. I wouldn't. Okay, so tell me what you got for your next one.
Okay, so the next one I got is 122,998.
Yes, correct. Okay. And do you need to round that one? Because I got 0.46. So if you rounded the 5,
Yeah, round to the nearest whole number. So
would you round 8 or would you just keep it? Because mine I got 0.466. So
yeah,
technically, if we're rounding, put a 9.
no, I would still round down because
Round down.
yeah.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are, okay, I think I have. Okay. I have a simple random sample is drawn from the population. The distribution of the sample mean is normally distributed. Sigma is assumed to be known.
Okay.
All of the above.
Okay, good. Let me just make sure I put in answers for all of these because sometimes I don't.
Yeah, that's not good.
Okay. So, is that it? Then we're done?
Mm.
Okay, I'll submit mine. Okay, 100%. Good.
Yay.
Yay. All right, so
Okay, now 11. Okay. I'm opening my 11 group meeting, L11.
quiz, okay.
True.
Okay, so are you to 3 yet?
Yeah, I'm a 3.
Okay.
So in previous lessons, we have assumed the population standard deviation. Sigma was known in this lesson. We are making a different assumption about sigma. What has changed? We assume sigma is unknown, right?
Right.
Okay.
Okay. The null hypothesis is mu equals 8, and the alternative hypothesis is mu is greater than 8, and the population standard deviation is not known. Becca collects a sample size of n equals 9 and computes x bar equals 11 and s equals 6. Use this information for questions 4 through 5. Is sigma known? No. Really basic so far.
Okay, what is the value of t?
Okay.
Round to 1 decimal point. So we can put this. Okay, so my question is how can we put this information to find t, or do you just do it by hand?
Okay, so there's a formula, and
Right.
it's just like the z-score, except you're substituting, instead of using sigma, you use s, because
Right.
sigma's not known.
So when I was in the lesson, it talked a lot about just doing the t-score through SPSS, you know, or using your Excel. Have you been just doing it by hand?
On this one, I would do it by hand, because usually when they do SPSS, they usually have like all the data set that you have to open up in SPSS.
So that was my question, is if we were supposed to figure this out by hand or in SPSS, because a lot of them, like, you know, in part 2, it's like, okay, now use your, granted, there's data, there's like data, but okay. I was just there was something else.
It seems like when they want us to use SPSS, they'll have a link for us to go
Right.
data.
Do it.
Mm-hmm.
Plug into T.
Okay, what's that?
What do you solve for T?
Yeah, so the formula is already solved for T. The one that I'm using is T equals x bar minus mu.
Oh, okay, I see. Sorry, I was using the wrong formula. That's why I'm like, wait, I'm confused.
So it's x bar minus mu.
Right.
Numerator divided by s over the square root of n.
So this one is 2. So tell me, okay, I have my answer. Tell me what you, or I got 1.5.
Yeah, that's what I got. Okay, so this next one is kind of tricky. It says use the following values which were pulled from the data file body temp. Body temp. Copy and paste them into the software you are assigned to use. Quantitative inference procedures, Excel, spreadsheet for 221, and SPSS for 222 and 223. We're 221, aren't we?
Yeah.
But I haven't been using Excel. Have you?
I haven't either. I think you're only supposed to use Excel if you can't access SPSS. Because remember, Anthony said that he used Excel for one of his.
Okay. So do you think we can just go to the body temp .save and pull it up rather than typing it all in?
I think so.
Okay, let me try that. I guess we'll find out if our answers are matching or if they're right. Okay, let me see. No, not right now. I need you to come out because I'm taking your quiz. Okay, let me just. I can figure out where to get the.
I don't like when they do that. I like when they're like, okay, pull this up beforehand. You know what I mean?
Yeah, then you don't have to go leave your quiz and try to find it. I don't know.
Annoying to me.
It seems like this is the first time that they've done that, though.
Yeah, it is. That's why, because I looked beforehand to see if they had us use anything. Where's mine? Mine's up. So, okay. Okay, so I was able to copy and paste mine in pretty easily.
Okay.
So, okay.
Do that because I can't seem to be able to leave this page without. Anyway.
Okay, so what is X bar? So, hold on, I'm going to have to make this big really quick and all. So, X bar, I go to analyze, compare means, and then one sample t-test, correct?
To find X bar, you can just do descriptive statistics.
Descriptive stats and do explore.
You want us to find X bar? Yeah.
And what's our, I guess it doesn't matter what our confidence interval is, huh? And
No, it's usually set at,
set at 95 right now.
yeah.
Okay, so I'm just going to push OK. Okay, so our X bar is going to be our mean, right? So it's going to be,
Oh, okay, there it goes.
get yours.
Yeah, I did. That wasn't too bad. Yeah, so it's just going to be your mean.
So 98.22. Round to 3 decimal places. 98. Are you putting 0.220?
98.220. Yeah, let me. Now I have to pull up my test again. Hold on. Okay. Why is this hard?
Here, why don't I read the questions to you really quick since you have your SPSS up and we'll both do it together.
Okay.
And then
What did you get? 98 point what?
98.220.
Okay.
So then it says, what is S? So S is our sample, right? Our sample size.
No, that would be N. S is our standard deviation.
Oh, yes, you're right. You're right. Okay.
Okay, let's try that.
So our standard deviation would be 0.92201. So 0.922.
Mm-hmm.
Then what is our t-score? Okay, I'm going to have to do that other thing real quick. Hold on.
Wait, why did I put one?
So I go to analyze, means, one sample t-test, that over there. What is our confidence interval? Or I mean, not our confidence interval, I'm sorry. What's our percentage that we want? Because you know how you have to put in a test value?
Yeah, it's, hold on, I'll give it to you. It's going to be mu, which is 98.6.
Okay, and I got our t is negative 1.843. Negative 1.843. What is the p-value? And our p-value is, my thing.
Okay, so p-value.
Our p-value is the sigma 2 tail, right? But you only divide it if you're doing a one sample, right? I mean a one tail.
Right, but it is two tail. It is one tail, because our alternative hypothesis is that mu is less than 98.6.
So then I need to divide our p, correct? 0.
You put it into the.
Because the one that, well, no. So I have it up in that thing, but it makes it as a two-tailed, not a one-tail. Remember?
Oh, wait a minute. So, sorry. Is there a different applet for the t-score?
No.
No, it's the same one.
Yeah, I think so.
Okay. So you would just shade to the left for the p-value and put in.
Wait. I thought the p-value, because on the videos, remember, if you pull it up in the thing, it talks about how, like, it has your p-value, and it's the sigma two-tailed or whatever, but you have to divide by 2 if it's a 1, if it's not two-tailed. Is that ringing a bell at all?
Yeah.
So I have it up. I don't know if I can share my screen with you.
So you're saying you shade both tails and then you just divide by 2.
Yeah, well, I didn't even shade it. It gives you it in the SPSS, the p-value. Hey, Ken, stop. Do you know what I'm talking about?
Not really.
Okay, so hold on. How do I share my screen with you?
You just click on the left-hand side, screen share. It's the little green computer with the arrow, the white arrow. And it'll give you options, and you just, click on what you want to share.
Oh, it doesn't pull up my SPSS. Dang it. So let me see if it gives me the option if I make it small.
So for the p-value, I just got 0.033, I guess.
Okay, hold on. I'm gonna start screen sharing with you real quick.
Okay.
Okay.
Oh, you mean it has the p-value? It gives it to you in SPSS? Is that what you're saying?
Yeah.
Okay, so I don't have to put it in my applet.
Right, exactly. So see this? Can you see my screen at all?
It's tiny. Let me get it bigger. Hold on. Okay.
So see this sig two-tailed right here?
And it says.
Isn't that the p-value, but they assume that it's two-tailed, so you have to divide by 2.
I forgot about that. Okay, so, that makes it easy. So it says 0.061. Is that what it says?
It says 0.081. So if you divide by 2, it's 0.0405.
Oh, okay. Huh, okay. So that's different than what I got. You know why? Because, I think it is different. You can't use the applet for it.
Is that right, though? Does that make sense?
Distribution is different from a t distribution is different from a normal distribution. So that makes sense. Okay, so let me just make sure that my I'm glad you remembered that my SPSS says the same thing. Divided by 2. Yep. Okay, good call. So 0.041, is that what we'd want to put?
Yeah, and I'll submit mine first, just in case, so we'll know, but...
That's fine, but I'm sure you're right. Okay, what is the correct decision based on this evidence?
So our p-value is not greater than alpha, so we can accept, right?
Is our alpha 0.05, is that what it is?
Yeah, our alpha is 0.05.
So it's less than 0.05, so you reject the null.
You reject the null if it's less?
Yeah.
Oh, right. If it's greater, then you accept, or you fail to reject, right?
Yeah.
I always mix those up. Okay. So, the hospital claims that the average birth is 4 minutes in plans. Relocation claim, you want to test their claim, you select U40.
Okay, so I can't see the bottom number there. It says, okay, values are.
What
you know
number?
what?
Let's see, sorry.
Okay, hold on. Let me just rearrange my screen. Maybe that would help. Oh my goodness. Sorry, having technical difficulties.
You're okay.
Okay, so what number are we on?
Sorry, hold on. We should be on 11 right now.
Okay, so. Are you able to copy it and paste it?
I just need to open the SPSS again, just because. It kept calculating my other scores. Jeez, this takes a while with just 2 of us.
Yeah, it does. Okay, so now what is that?
Okay, so. Compare means 172. Variance test value is 40. Okay. Okay, so tell me what you get for your p-value.
Hold on, I need to pull it up again. So mu is 40.
Yes.
So.
Except, what does this mean? And you see a level of significance of 0.01. What is that value to us?
That's our alpha. So
alpha.
It's usually 0.05.
Oh, okay. It just without the, I don't know.
Yeah, you can choose 0.1. Wait, is it anywhere between 0.01 and 0.1? And we have just been using 0.05 in this class, but you can use 0.01 or 0.1. So, okay, so I got the sigma two-tailed is 0.995. Now,
Correct.
is it one-sided or is it...
Okay, that's how I don't know. How do you know if it's one or two-sided?
Okay, hold on a second. Let me look at the problem again. So I think our alternative hypothesis would just be that mu is not equal to 40, so it would be two-sided.
Wait, so how do you know that? How do you know it's... Because I don't understand that.
Okay, so we're just testing their claim, and they're claiming that mu is equal to 40. It doesn't say that we think it's less than 40 or more than 40. We're just testing if it is 40 or not 40. Does that make sense?
So it's two-sided because...
Because our alternative hypothesis is mu not equal to 40.
Mu is not.
So we want to know if it's 40 or if it's significantly higher or lower than 40.
Oh, okay, I see. So our thing would be 0.995 then.
Yeah.
And then in that decision, our p-value is
Oh, wait a minute.
minor, right? What is the p-value?
You know
So
what? Because we have to actually go in and change the level of significance, though. Because it automatically does it for a level of significance of 0.05. So I think it's...
How do you do that?
I think it's different. I'm not sure, but I think it might be different if we change it. Let me look at that real quick.
How do you change it?
I'm not sure. Let me look. 40 options, maybe? Yeah. So it has the confidence interval at 95%, which I think corresponds to alpha being 0.05.
Wait, but then our other one's wrong because we didn't change. I don't think you have to change your alpha.
You only have to change it in SPSS if it's not 95% or if it's not 0.05 for your alpha. Because 95% confidence level corresponds to 0.05. I think it matters, but I don't know. I'll change it and see if we get it or not.
Where exactly do you get 95% equals 0.05? That's what I don't understand.
Alpha is equal to the probability of committing a type 1 error. So 95% is the same as 0.95. So that's your confidence level. So then alpha is going to be the 0.05 that's left over.
Oh, okay, I see what you're saying.
So if our confidence level, so if alpha is 0.01, our confidence level is actually 99%.
Okay, I see what you're saying.
Let me see if, I'm going to put that in and see if that changes our p-value. So I still got, wait. What did we get before?
0.995.
Okay, so I still got 0.995, so maybe it doesn't matter for the p-value. I think it just matters for,
Good.
I don't know.
Good thinking, though, that I didn't even think of.
Because it matters for t,
Right.
but maybe it just wasn't big enough to matter for the p-value.
Yeah.
Okay.
Okay, so then we failed to reject the null hypothesis because it's bigger, correct?
Right.
Okay. You decide to try another alternative hypothesis. Time you use mu is less than 40 and keep the same level of significance. Did the p-value increase or so? I don't know.
So then it becomes just one-sided. So you'll divide your p-value by 2.
Oh, okay, I see what you're saying.
So, hold on.
5 divided by 2. So then it's 0.4975, so it decreased.
Yeah.
What decision do you make? We still fail to reject the null, correct?
Yes.
And then compare the width of the confidence interval for question 11 to confidence interval for question 13. Which one is wider?
Okay.
So our confidence interval for this one is 22, negative and positive 22, and then our other one, crap. Hold on, I can pull it up really quick on mine.
So for 11 and 13?
Yeah.
Okay, hold on. Would they be different?
Oh no, they wouldn't be different, would they? They are the same, right?
I don't know. I'm trying to think. My brain is tired. Sorry. Okay.
Value.
I think they would be the same because the only thing that changed was that it's two-tailed or one-tailed, but your confidence interval. You'd still have the same data set and the same mean and the same confidence interval for 95%. I think it would be the same.
I think so too.
Okay. Let me check and see.
Okay, I will submit mine first.
Okay, I'm just going to check and make sure I put answers in all of mine. Sometimes I forget that part. Oh, good, yay!
Yay, we did it. Okay, excellent. Good job.
All right. Well, thanks. Hopefully, Jessica, I don't know what we do if they just don't.
Well, we all agreed on this time, right? So
Yeah.
I never got anything saying that nobody could make it earlier, so I don't
So
know.
they're kind of on their own, I guess.
Yes, I mean, I have to go to work, so if you want to help them, but I don't know if they'll contact you or not, because I still haven't heard from Anthony.
Okay.
So, I don't know. We'll just see what happens. So.
Okay. Yeah, I'll just wait to see if they contact me then. Okay. So do you want to post it then?
Yeah, I'll post it.
And then I guess we'll just wait. I don't know, to hear from Anthony about a schedule.
That sounds good. We'll do that.
Okay.
Hey, thanks
Sounds
again.
good. All right. See ya. Bye bye.